So here we're trying to simplify a trig expression, and there's no real easy kind of step-by-step solution on how to solve these. Best way I can try to explain it is it's a puzzle you're trying to solve. You got to deal with the pieces individually and kind of try to break them down in parts. So for each sine, secant, tangent, I'm going to kind of spread it out separately. So it's the equivalent of secant times sine times 1 over tangent. If you kind of spread out the pieces like that and work with them individually, you might kind of see how things come together. Maybe rotate a piece, see how it fits differently. Well, secant is 1 over cosine. So I'm going to rewrite secant as 1 over cosine. That rearrangement kind of enables you to now fit it with sine. Sine over cosine, we all know to be tangent, right? Well, if sine over cosine is tangent, now it's basically reduced to tangent times 1 over tangent, which is just 1. So basically we separated the pieces of our original expression, just separate pieces, kind of try to rearrange them, rework with them to see what cancels, to see what simplifies. That's the best way that I can try to explain this process. Each problem is going to be different. Each problem is going to kind of have its own path to take. One path might be different than another. It just takes practice. So here's another one. 1 plus cosine x all over 1 plus secant x. I'm going to work with secant. Secant is 1 over cosine. So in the denominator, I now have 1 plus 1 over cosine. I'm going to work with just the denominator. I'm going to try to find a way to add 1 plus 1 over cosine x. And to do that, I need a common denominator in the denominator. Well, that common denominator would be cosine of x, right? So the denominator is going to be cosine x over cosine x plus 1 over cosine x. It's going to get messy at times, but sometimes the mess kind of simplifies to something nice, to something better. So now I can add the denominator, and what becomes nice looking is that in the denominator I have cosine x plus 1, which mimics what I see in the numerator, right? Both have this 1 plus cosine x. So that's going to kind of tell me something's going to cancel. So if I rewrite my most recent step to 1 plus cosine x over 1 divided by cosine x plus 1 over cosine x, that's where I'm going to see my cancellation. If I'm going to divide two fractions, that's like multiplying by the reciprocal. So if I rewrite my problem, it's 1 plus cosine x over 1 times cosine x all over cosine x plus 1. That's the aha moment. That's the nice looking thing in which I now see what's going to cancel. 1 plus cosine x is going to cancel with cosine x plus 1. So through all that mess, I had a nice cancellation. My original problem is just cosine x. So here's one more example we'll do together. Secant squared x minus 1 all over secant squared x. So every problem is different. This takes practice. let's separate this into two pieces. Secant squared x over secant squared x. We can't do that for a reason, right? Because we all know that's going to be 1. So that minus 1 over secant squared x. Well, that first part again is 1. So we got 1 minus 1 over secant squared x. Well, that's just cosine squared x. So we've gotten rid of the denominator completely. And 1 minus cosine squared x is nice. It's just sine squared x. So my original problem is sine squared x. Okay, so the 3 problems we just did, I want to check graphically. How can we check this graphically? The first problem we did, we believe that it simplified to 1. So let's check that. Let's graph that original problem. The original problem was sine x times secant x all over tangent x. So using your graphing calculator or using desmos.com, let's graph that original problem. Sine x, secant x, all over tangent x. And when you type that in, you get this line through y equals 1. And that's exactly what we thought it should be, right? Sine x, secant x, all over tangent x should be 1. So it should be the exact same thing as if we graphed the line y equals 1. Here's the second one we did. We think that it should equal cosine x. So that's the blue line that I have graphed on desmos.com. The blue line is cosine x. Well, when I type in my original problem, 1 plus cosine x all over 1 plus secant x, the graphs should overlap. They should be the same exact graph. That's how we'll know that we simplified the original correctly. So there's both graphs put in. The red one matches the blue one. So we know they're equivalent. We know that we simplified the original problem correctly. Alright, let's check that third one. If we type in the original, secant squared x minus 1 all over secant squared x, it should match up with the graph of sine squared x. So put those both into your grapher and let's see if they match up. So in red here we have the original. Let's see if it matches up with sine squared x. So in blue I'm going to graph sine squared x and we'll see if they match. Yes, they definitely do. So we simplified correctly. So I'll do a few more examples with you. I'm not going to walk you through it with my voice. I won't bore you with that. I'll play a little music in the background. But try to see what my steps are. Again,